Good afternoon. Our product is 3M Sun Control Films, a project by Brandon, John, and Shankara. To begin, we'll first be talking about uses and a good introduction of what 3M Sun Control Films are. So, although windows can be great and let in a lot of natural light, they also have the capacity to create excessive heat, fade valuable furnishings, and cause harmful UV rays. The technology employed by 3M Sun Control Films allows you to not only let in light while keeping heat and damage out, it does so by a film coating on your windows that can be used at home. For commercial applications, this is incredibly valuable not only because of its practicality, but because it may do so without changing the appearance of the window.
These window films, combined with the actual glass, are referred to as transparent heat mirrors. They reflect infrared and UV light while allowing the transmission of visible light. The film itself is known as a DMD, a dielectric metal dielectric. These components are manufactured through a method called physical vapor deposition, specifically sputtering. In this process, some neutral gas, such as argon, bombards a source material such as silver or gold, which releases gold and silver atoms and allows it to be deposited onto a layer or a film on a substrate.
This product, as previously mentioned, utilizes multi-layer dielectric-based films. What this essentially means is that your base substrate, say the glass of the window you're hoping to modify, will be coated by the film that consists of the following. First, an insulating layer, generally made out of titanium oxide, which serves as anti-reflection and protection purposes. This is generally between 150 and 500 angstroms. The second layer in between is a metal layer, generally made out of silver. What this does is reflects infrared and thermal energy. It allows higher frequency waves to pass through and is generally between 30 to 200 angstroms. And then finally, the second insulating layer, also made out of titanium oxide usually, is phase matching, and it spans between 30 and 200 angstroms.
The reason we specifically designed with silver is because it has high infrared selectivity, has high transmission to solar radiation, and it allows for little absorption of light below 500 nanometers. As can be seen by the diagram on the right, when silver is paired with our titanium dioxide, we get a unique set of properties that are optimal for letting in visible light but reflecting the IR and UV rays. So as we see, we get exactly what we want, a high transmission between 350 and 800 nanometers. Visible light wavelengths are in the range of 390 to 750 nanometers. Anything above that, we see very high reflection by the silver for a micron and above. Other materials such as gold or chrome show significant absorption below 500 nanometers, and so we're unable to take advantage of the visible light that's coming through, and that's actually reflected in alternate materials. Here we see an image of the microstructure of the silver film as imaged by a transmission electron microscope.
So putting it all together, we first use a silver layer of about 50 angstroms thick. This is the best thickness for use in window films. It's not too thick to compromise solar transmission, but it's not too thin to feasibly deposit as a film. Next, we use the two titanium oxide layers that go on the outside. The anti-reflection layer is transparent to solar and infrared radiation, and in conjunction with the phase matching layer, cooperates to minimize visible light reflection losses by the silver layer. Now we'll look at a demonstration of how this works specifically. Light comes in and passes through the first anti-reflective titanium oxide layer, hitting the layer of metallic silver. Here is where the specific split happens. UV and IR radiation is reflected back towards the outside, while a majority of the visible solar radiation is transmitted through. However, silver does reflect some of this visible solar radiation. The two titanium oxide layers work together to prevent this visible solar radiation from reflecting back to the outside, redirecting it to transmit through the entire film into the building.
By taking advantage of silver and titanium oxide's chemical and crystalline properties, 3M has been able to manufacture technology with both commercial and industrial uses.